Alright, separable differential equations. Alright, skipping a couple pages here. So, we've already graphed some of these, and we didn't do the numeric method, so just ignore that says there. Okay, that's a BC topic, and I don't feel like we need to take that time to do that right now. Alright, so on to example 1 here. Solve the equation, then find the particular solution, blah, blah, blah. So, the first thing that you must do, or you get absolutely no points for this problem, would be show the separation of the variables. So we have y squared, we multiply both sides by y squared, okay, equals x squared dx. So you'd probably get a point for that if this was a free response question. Take the integral, okay, 1/3 y cubed equals 1/3 x cubed plus c. Alright, so now 1/3 y cubed. We need to solve that for y. That's what it means to solve the equation. Alright, so multiply everything by 3. So if we multiply c by 3, it's still a constant. Alright, so I don't have to write 3c there. Now I'm going to take the cube root. There we go. Alright, this is called, oh, I've lost my equals. That is the general solution. Okay. Sometimes they ask for the general solution, but in this case we want the particular solution that satisfies each of the 3 initial conditions. Alright, so I'm going to show them a little bit differently. So I'll say when. I guess I should write just like they did. So when y of 0 equals 2. So we're talking about this graph right here. Then we have 2 equals the cube root of 0 plus c. Cube both sides, we get this. So y equals the cube root of x cubed plus 8. Alright, that is the equation of that green line that I drew. And you can graph it on your calculator and see if it looks like that. It should. Alright, the next one, let's say when y of 0 equals -2. So we're talking about probably this line. We have -2 equals the cube root of c. Alright, so we get -8 equals c. So y equals the cube root of x squared. I meant x cubed. Alright, let's try that again. X cubed minus 8. Alright, and then last but not least, when y of 0 equals 0, we get 0 equals the cube root of c. Cube both sides, you get c equals 0. So we get y equals the cube root of x cubed, also known as x. So we have each of those 3 particular solutions there. Great. Alright, moving on. Find the general and particular solutions to this equation given the initial conditions. Alright, so I know this is going to take a little bit of space, so I'm going to write a little bit smaller. So separate the variables. Now 1 over y, if we want to take the antiderivative of that, it's ln absolute value of y. Okay, 1/3 x cubed plus c. We need to solve this for y. Alright, so if I e both sides here, we get e to the, and I could write that as x cubed over 3 plus c. Oh, I write the plus c in the exponent. There we go. Now, so here's a neat property with logs, right? Another way to write this is e to the x cubed over 3 times e to the c, right? This is properties of exponents here. Now, e to the c is just a constant. So I can write now constant, big old constant times e to the x cubed over 3. Alright, and now that constant can be positive or negative, so I won't need my absolute values anymore. So my general equation is this. Alright, now I have 2 that I'm going to try to give the initial condition, so we'll say when f of 0 equals -2, e to the 0 is just 1, so c equals -2. So the equation, I'll say so, y equals -2 e to the x cubed over 3. Alright, and now if we graph that, f of 0 equals -2, and follow our slope field here, it looks like it would look something like this. And if you graph it on your calculator, you can actually check that, and you should get that same equation. Trying this one now, when f of 0 equals 1, we have 1 equals c, and again e to the 0, so 1 equals c. So y equals e to the x cubed over 3, and f of 0 equals 1, that'd be about there probably. Alright, so if we follow this, it might look something like that. Okay, great. So we have both of those. So we have the general and the particular equations given the initial conditions. Now this one was actually on an AP exam, so we'll follow this and see what we can do. Here we go. So the first thing, find the slope of the graph at the point where x equals 1. Well, notice that we have more than just an x. We have an x and a y. But they gave us that point. Alright, so for part A, you are simply writing, okay, you should show what you're doing. You're going to plug in the 0.14, and then plug it in. So 3 times 1 plus 1 over 2 times 4, it's 4 over 8, or 1/2. There you go. First part done. Now you're already getting points for doing that. Now write an equation of the line tangent. So we have x equals 1, and we have our slope, right? So we'll call it f of x, I guess. It doesn't matter. F of x equals 4 plus 1/2 times x minus 1. And we're trying to approximate this. So maybe I shouldn't call it f. Maybe I'll call it L for line. Okay? So f of 1.2 can be approximated by L of 1.2, which equals 4 plus 1/2 times 1.2 minus 1, which is just 0.2, times a half is 0.1, so we get 4.1. Alright, next part. Find f of x by solving this equation. Alright, so I'm going to try to make this a little bit smaller. There we go. So we have 2y dy equals 3x squared plus 1 dx. Integrate both sides. So you get y squared equals x cubed plus x plus c. Solving for y, we get plus or minus this. There is my general equation, but I need to solve it with that specific initial condition. Alright, so we could say when f of 1 equals 4, if 4 equals, we'll leave that plus or minus for now, 1 plus 1 plus c, square both sides, so we get 16 equals 2 plus c, c equals 14. Now, we could write it up here, so y equals, notice I left a little bit of space, x cubed plus x plus 14. So I don't know if it's going to be the positive part or the negative part. If I just plug in my initial condition 1, in order to get 4, this would have to be positive. So I'm going to leave it like that. There you go. And last, use your condition from part C to find f of 2. So I'm going to say, it says, I'm going to just change my notation here, f of x. Okay, because it says find f of x. Alright, use my solution now from part 4. So we have f of 1.2. Now, if this is a non-calculator part, you wouldn't even try to do this, okay? Don't waste your time. But I have a calculator handy. And I think this is about 4.114, which is very close to what our approximation was in the beginning. So there you go. That problem hopefully wouldn't be too bad if you got it on the AP exam. Alright, so one of the last things that I'll introduce today is this law of exponential change. And hopefully you remember part of this in pre-calc. You should have done some of this. We'll talk about it. So if a rate of change is directly proportional, then that means that the rate of change, the derivative, is directly proportional. It's some constant times y. And if that happens, we're going to get this y equals c e to the kt. All right, and we'll show that here. So if I solve for y, I get 1 over y dy equals k dt. All right, so I get ln, absolute value of y, because I'm integrating both sides, equals kt plus c. Oops. I'm going to raise both sides using the power of e. So I get y equals e to the kt plus c. But remember from my last problem, I said that you can write it as e to the kt times e to the c. Now I could drop that absolute value, y equals c e to the kt. So if we recognize that it's a proportional growth, okay, or exponential growth, then we can just jump right to this equation. All right, we'll do one example, and then we'll do the rest at another time. All right, here we go. So find an appropriate equation to model this. So we have bacteria in a culture. It increased from 400 to 1600 in just 3 hours. All right, so we know that is an exponential growth, so I can start with this equation. All right, we have 400. So it's like this point, 0, 400, and this one would be 3, 1600. We're just plugging those points into this function. All right, so c times e to the, that would be 0. So 400 equals c. Okay, so now I have 1600 equals 400 times e to the 3k. Let's keep going. 4 equals e to the 3k, solving that. ln of 4 equals 3k. 1/3 ln of 4 equals k. We have our constant and proportionality here. So we could pull that all together as y equals 400 e to the, let's see, I could write it like this. I could write it numerous ways. ln of 4 times t. All right, but I'm going to change colors here and write a little bit smaller because I want to show you something neat. Y equals 400. I could write it as t over 3 times the ln of 4. Remember, whatever's being multiplied, I could bring it to the exponent. So I get 400 ln of 4. Oh, I lost my e, didn't I? There we go. E to the ln of 4 to the t over 3 power. If I do that, my e and my ln could cross out. So I get 400 times 4 times t over 3. Okay, which is possibly what you could do from pre-calc. Because we go from 400 to 1600. We quadrupled in 3 hours. So that's where that divided by 3. So you can use either of these functions to do part B. And part B, plugging in 6. This one might be a little bit easier without a calculator. 6 over 3. So that's 400 times 4 squared is 16, or 6400. And you should label anytime you can with units bacteria. There we go.